Hello everyone, I am Dr. Tokkummaa Geetahuun and this is chemistry tutorial organized and sponsored by Oromia Education Bureau. This is the third topic selected from different areas of Oromia region, and that is polarity in covalent molecules. How can we identify whether a molecule is polar and non-polar? So I'm going to tell you about this one. For example, if all electrons are transferred from one atom to another atom, ionic bond is formed. But for example, in the sharing of electron, that is if in the covalent bond, if electrons are unequally shared, simply that is polar covalent bond. If electrons are equally shared, that is nonpolar covalent bond. And the molecules that contains nonpolar covalent bonds are known as nonpolar molecules, and the molecules that contain polar covalent bonds are known as polar molecules. So I'm going to tell you about this one, and there is also a table that guides you how to identify whether the bond is polar or non-polar. I'll tell you this one later. Okay, so let me start my presentation. What is molecule? This is nothing but it is a group of two or more atoms held together by chemical bond. If that bond is covalent bond, if the atoms are held together by covalent bonds, these type of molecules are known as covalent molecules. Okay, nonpolar covalent bond. How can we know whether the bond is polar or non-polar? If the electrons are equally shared between two similar atoms, so the bond formed between these two atoms is known as nonpolar covalent bond. The covalent bond formed by equal sharing of electrons between two similar atoms. So the polar bond and the nonpolar bond can be identified based on the electronegativity of the atoms. If there is equal sharing between atoms, for example here, this is hydrogen atom, this also hydrogen atom, two similar atoms. So the electrons shared by two similar atoms, this sharing is equal sharing of electrons between the atoms. Therefore, nonpolar bond is created. Nonpolar bond is formed. We can identify by looking the atoms that participate in the bond formation. Two hydrogen atoms. In these two atoms, if, for example, they share equally the electrons, therefore the bond formed is nonpolar covalent bond, equal sharing. So as a result, electron pair is situated exactly between the two nuclei. Between the two nuclei. Electron is at the center of the nuclei of the two atoms. So this indicates equal sharing of electrons between the two atoms. So for example, the bond formed between two hydrogen atoms, that bond is nonpolar bond. Okay? The bond formed between two oxygen atoms, an oxygen molecule, is also nonpolar covalent bond. Between chlorine atoms, nonpolar bond. Between similar atoms of nitrogen, that is also nonpolar bond. Between bromine atoms in bromine molecule, that is also nonpolar bond. So all these are homonuclear diatomic molecules. The bonds in these all heteronuclear diatomic molecules are nonpolar covalent bonds because there is equal sharing of electrons between the atoms of these homonuclear diatomic molecules. Electron is distributed symmetrically within the molecule. If there is symmetrical distribution of electron between the atoms of the molecule, that bond is simply known as nonpolar covalent bond. But if, for example, electron density is distributed unsymmetrically within the molecule, the bond is polar covalent bond. Okay, so polar covalent bond. Already I told you about this one. When covalent bond is formed between two different atoms. Between two different atoms means, for example, they have different electronegativities. If, for example, the range or the difference in electronegativity between the atoms is greater than or equal to 0.5, the bond is polar. I'll tell you this one later. But here, there is unequal sharing of electron between what? Two different atoms. So the bond formed is simply known as polar covalent bond, an equal sharing of electrons between the atoms. Look at this picture. This is chlorine, but this one is hydrogen. The two electrons are closest to chlorine atom. Why? Because of the electronegativity of chlorine. I told you that electronegativity is the power of an atom to attract electrons to itself. Therefore, there is an equal sharing of electrons between these two atoms, chlorine atom and hydrogen atom in hydrogen chloride. Therefore, this is best example for polar covalent bond, and the molecule is also polar molecule. The molecule that contains polar bond, they are known as polar covalent molecules. So there is an equal sharing of electron. This is because of the electronegativity difference of the atom. For example, the electronegativity of chlorine is 3.0 and the electronegativity of hydrogen is 2.1. So the difference, this one is 3, this one is 2.1, the difference is 0.9. So it is greater than or equal to 0.5. So there is an equal sharing of electron. Due to this, the bond formed between hydrogen and the chlorine atoms is known as polar covalent bond. This is best example. The bond between HCl, the bond between hydrogen and the fluorine atoms is also polar covalent bond. And the say type of, for example, bond can be represented as H delta positive and Cl delta negative. Because of the electronegativity of chlorine, chlorine attracts the electrons to itself, so it acquires this delta negative. Okay, it is also named as partially negative. Okay, this is partially positive. The more positive is partially positive. Or hydrogen has smaller electronegativity when compared with that of chlorine atom. So due to this, hydrogen acquires this delta positive. So it is partially positive, positively charged. So atom in this bond formation, Cl acquires partial or slightly negative charge, that is delta minus, whereas hydrogen acquires partially positive charge, that is simply known as delta plus. So this indicates an equal sharing of electron. The electrons are closer to the nucleus of chlorine atom. Why? Because of the electronegativity of chlorine. It attracts these electrons to itself because of its electronegativity. So there is an equal sharing of electron. Therefore, the bond formed between hydrogen and the chlorine atoms is polar covalent bond and a relatively higher electron density near chlorine atom. So electrons are asymmetrically distributed between hydrogen and the chlorine atoms. So electron densities are near chlorine atom because of the electronegativity of chlorine. So we can identify the polar covalent bond based on the electronegativity of the atoms participated in the bond formation. Bond types using electronegativity difference. We can easily determine, okay, whether the bond is polar and non-polar by using the electronegativity. Okay, let us see, okay, some examples. The bigger electronegativity difference, the more polar the bond. Okay, look at this table. The most electronegative element is fluorine. Its electronegativity value is 4.0. And the least electronegative element is CCl. Its electronegativity value is 0.7. So the range of electronegativity is between 0.7 and 4 according to Linus-Pauling scaling of electronegativity values. So this one guides you, okay, to identify whether the bond is polar covalent bond or non-polar covalent bond. For example, if the electronegativity difference of the two atoms is in the range between 0 and 0.4, that bond is non-polar covalent bond. For example, look at this example, hydrogen molecule. What is the electronegativity of hydrogen? It is 2.1. 2.1, okay? The electronegativity of another hydrogen atom is also 2.1. 2.1, this also has 2.1. 2.1 minus 2.1, it is equal to 0.0. So this value is in the range between 0 and 0.4. Therefore, the molecule is this bond. The bond between these two hydrogen atoms is non-polar covalent bond. We will also see another example. Okay, if the electronegativity difference range is between 0.5 and 1.0, the bond is moderately polar covalent bond. For example, look at this example, HCl. What is the electronegativity of chlorine? It is 3.0. Okay, 3.0 for chlorine. What is the electronegativity of hydrogen? This is 3.0 and this one is 2.1. 3.0 minus 2.1, it is equal to 0.9. This value is in the range between 0.5 and 1.0. Therefore, the bond created between hydrogen and the chlorine atoms is moderately polar covalent bond. So you can easily identify whether the bond is moderately polar or non-polar or highly or very polar covalent bond.